Hey guys, with this problem solving course, I want you to introduce the concepts and algorithms needed to crack a technical coding interview. I know there are tons of videos and books out there which take up a topic, say stats and queues, and then give a bunch of questions in the exercise sections to practice that particular concept. For example, if you're learning about linked list and in the exercise you encounter LRU cache question, then you know you want to somehow implement this as a linked list. And this particular case, you might use a doubly linked list, right? So it narrows down the thinking or pattern to use a particular data structure given the problem. But I believe that the thinking should be reversed because when you enter an interviewing room, you're going to be hit straight with a question such that find X given Y. You don't know what data structure to apply, you don't know what algorithm it associates with. So that's how each video in this course is modeled. We'll take a particular question and try to understand the thinking behind that using a particular algorithm or data structure and apply to that question. Let's see an example. Let's see this problem. One day, N friends gathered together to play the game of Mafia. During each round of the game, some player must be the supervisor and other N-1 people take part in the game. So let's say 3 people are playing the game A, B, and C. So somebody has to take a position of supervisor in each round and they can play multiple rounds. For each person, we know in how many rounds he wants to be a player and not the supervisor. The ith person wants to play A of I rounds. So person wants to play 3 rounds, B wants to play at least 2 rounds, and C wants to play 2 rounds too. What is the minimum number of rounds of Mafia game they need to play to let each person play at least as many rounds as they want? So suppose in the round 1, they play B and C and A becomes the supervisor, right? And round 2, they play A and C and B becomes supervisor, right? And round 3, they play C and B and A becomes supervisor again. So in this way, B has played 2 games, C has played 3 games, and A has played only 1 game here. So this doesn't satisfy. In 3 rounds, we cannot satisfy this constraint. So how many rounds such that we need? Let's think about the solution for a minute, and you can pause the video and I'll get to how to approach this problem. Right, so let's figure out the upper and lower bound of the number of rounds we can play. So of course, lower bound is we can play 0 rounds, and upper bound is what is the max number of rounds we might play. So let's say A, B, C, D each wants to play at least 2 rounds. I think we can safely assume that playing 8 rounds will definitely satisfy the constraints because we can make each player exclusively in that round, and even if rest becomes the supervisor, that's fine. So our answer lies somewhere between 0 to 8, right? If 8 satisfied, we also know that playing 9 rounds will satisfy the constraint, and playing 10 rounds will also satisfy all the players. So suppose this is the number of rounds, right? Where 0, 1, 2, 3, 4, 5, 6, 7, 8 up to whatever, and say 8 and 9 are here, then 0 doesn't satisfy, right? The constraint, and 1 not satisfy because they have to play 2 rounds at least. 2 doesn't satisfy because somebody has to be supervisor, and none of them somebody has to supervisor and somebody has to miss out the game. And see, it satisfies, 9 satisfies, and so on. So you see a pattern here, right? So somewhere along this line you might find a number here which will satisfy, and somewhere along this path you'll find which is not satisfied. So you want to find that point which gives you the right answer, right? This X, right? So whenever you see this sort of a pattern, what you can do is you can safely use a binary search technique on the answer itself, right? So here we are finding number of rounds, so just binary search on the rounds. So for example, try round 10. Does it work? Yes, it works. Then try round 0. Does it work? No. Then try round 5. Does it work? Yes. Okay, so answer lies somewhere between 0 and 5. Try round 2. Does it work? No. So answer lies between 0 and 5. Now try round 4. Does it work? Yes, it works. Then try round 3. Does it work? It doesn't work. Just like we saw in this example, many of the problems that you will solve in the interviews and in your future job as engineer are based on real world situations. that you want to analyze and figure out the data structure or algorithmic techniques that is best for the problem at hand. We would actually also discuss whiteboard coding and interview strategies approach, which is more common these days. This actually will also be followed by uh, complexity analysis and actual coding and uh, a coder pad style or a lead code style where we can run the solutions. We'll also discuss edge cases during those coding videos, and we'll also discuss testing techniques and how to structure our code so that it actually gives best signals about our coding skills. These videos in this channel can be watched in any order. I suggest that you guys do as much practice as possible because there are no shortcuts. I would suggest Lead Code, Spoj, and Code Forces. I think there are the good platforms to practice on. And if you want to deep dive uh, into different data structures that we'll explore in the upcoming videos, I would recommend the data structure and analysis book from Mark Allen Weiss. Link is in the description below. This is something I have used in our college, and I have never had to read up anything else to strengthen my basics. Also, though I have been primarily coding in C++ and competitive programming, I think the best language to use for interviews is Python. It's a weakly typed language, and it's actually very fast. You can code a very fast in Python in interviews that give you a slight edge where the interviews are constrained to like 45 minutes or 1 hour. Please hit like and subscribe to my channel. You will find links of the recommended videos in the end. Thank you and thanks for watching us, and let's get started.